Hey, welcome back. It's day 3. Today we're going to be talking about trig values of special angles and cofunctions, so 2 parts today. So first, we're going to be looking at trig values of special angles. And those special angles are going to be 30 degrees, 45 degrees, and 60 degrees. But as you should have seen in assignment 2's homework, right, we can take the trig value of any angle. For example, if you want, go ahead and type in sine of 10 degrees into your calculator. And let's see what we get, and let's talk about what this means. All right, so we will need our calculators today, so please grab them. And once we type this in, we're going to get 0.173648. And it actually goes on forever. It's an irrational number. And so what the heck does sine of 10 equals 0.173648 mean? Well, let's remember our trig definitions. Sine, we can get from SOHCAHTOA. The sine of an angle, theta, right, is equal to opposite over hypotenuse. So the sine of 10 degrees being 0.17, that's just telling us the ratio of the side length of the opposite side in the right triangle to the hypotenuse is 0.17 when the angle is 10 degrees. So here's a little picture. It's saying if this is 10 degrees, then that the sine of that angle, that's opposite, this is hypotenuse, that this ratio, if I call that x and y, that x divided by y, that's in a ratio of 0.173, whatever that is. Right, so again, all trig is just a way to relate side lengths and angles in the right triangle, at least for now. All right, so that was just a random arbitrary angle, but there are special angles that we need to know, and those angles are going to be 30 degrees, 45 degrees, and 60 degrees. So hopefully those angles look familiar, because yes, those are the angles that we saw in our special right triangles. So if I draw a 30, 60, 90 right triangle, this one has 30 degrees in it and 60 degrees in it. So let's use this 30, 60, 90 to get the values of sine, cosine, and tangent of 30 degrees and 60 degrees. So if I want the sine of 30 degrees, that's opposite over hypotenuse. So what is opposite 30 degrees? So I'm just going to make up a number because I know the ratio in a 30, 60, 90 is always the same. So let's make that 1. If that's 1, I know the hypotenuse is twice this length, right? That's the shorter leg because it's across from the 30-degree angle. So that will be 2. And the longer leg is radical 3 times the shortest leg, and that's radical 3. So sine of 30 then would be opposite over hypotenuse, 1 over 2. And again, this would be true in any 30, 60, 90 triangle, no matter what I made the side lengths. So for example, if I made this a length of 5, the hypotenuse would then be twice that, 10, and this would be 5 radical 3. Right, in this right triangle, or in this 30, 60, 90 triangle, sine of 30, that would again be 5 over 10, opposite over hypotenuse, which simplifies to a half. Right, so sine of 30 is always equal to a half, doesn't matter what triangle it is. And that's just telling us the ratio, again, of opposite to hypotenuse is a half. And that's always going to be true in any 30, 60, 90 triangle because all of these triangles are similar, right? And we know similar triangles have corresponding sides in the same proportion. So that proportion in this case is 1 to 2. And if we want to make it even more general than this, instead of 5 and 10, well, I could call this length x. And then we know the hypotenuse is always going to be twice that length, so we can call that 2x. And the longer leg will be x times radical 3. So in this triangle, if we do sine of 30, the general case, that's going to be x over 2x. So we can really see sine of 30 is a half. All right? So I'm going to use this triangle, though. It's a little easier. And let's get our other special trig values. So we need to know sine of 30. We need to know cosine of 30. So cosine of 30 degrees, that's going to be adjacent, right, which is radical 3, over hypotenuse, which is 2. And so cosine of 30 degrees is radical 3 over 2. So you need to know this value exactly. Your calculator will not give you that value. For example, let's all type in cosine of 30 right now into our calculators. The trig button is next to number 7. So type in cosine 30. Make sure you are in degree mode on the top right next to your battery. Make sure that says DEG. If it says RAD, you are in the wrong mode. If you're in the wrong mode, hit the on button, go to settings, and change your document settings to degrees. Right? But if you type in cosine of 30 into your calculator, you should get 0.866025 something something something. But if you also type in radical 3 divided by 2 into your calculator, go ahead and do that. That is equal to, of course, the same thing. Right? Because that's what radical 3 over 2 is equal to. Right? But I would never want to see the 0.866 version. That is not exact. The version we're going to use is cosine of 30 is radical 3 over 2. That's the exact value. All right? And lastly, tangent of 30. That's going to be 30 degrees is here. Opposite over adjacent. Right? So GOTOA. So opposite over adjacent is 1 over radical 3. Let's rationalize this by multiplying by rad 3 over rad 3. And that gets us radical 3 over 3. Right, so these are values that you need to know. Well, you don't need to know them, because you can always just derive it from a 30, 60, 90 rather quickly. But these are values that are quite important, and you should know these. All right? And of course, if you did it in this triangle or any other 30, 60, 90 triangle, we would get the same trig values here, the same ratios. All right? So next, we also need to know the sine, cosine, and tangent of 60 degrees. So here's our 60-degree angle. If I'm doing sine of 60, now my opposite side is radical 3. And the hypotenuse is still 2. If I'm doing cosine of 60 degrees, my adjacent side is now this guy, which is 1. Hypotenuse is still 2. And lastly, tangent of 60 degrees. Well, tangent of 60 is opposite, radical 3 over adjacent. So that's radical 3 over 1, which is just radical 3. All right, so we've covered our 30-degree values and 60-degree values. Now we want to know the trig relationships for a 45-degree triangle. So 45 degrees, we're going to draw our other special right triangle, which is the isosceles right triangle. If those are isosceles, these must be congruent angles, so 45, 45. And just like before, I can make the length of the sides whatever I want, but I will decide to make it 1. If that's 1, this is 1. And we know the hypotenuse is radical 2 times either of the legs, so the hypotenuse will be radical 2. All right, so sine of 45 degrees. There are two 45-degree angles, so it doesn't matter which one you look at. But if I look at this one on the bottom left, sine of 45, opposite would be 1, hypotenuse would be radical 2. And so that's 1 divided by radical 2. right? If I rationalize this, multiply by rad 2 over rad 2, we're going to get radical 2 over 2. Right, cosine of 45 degrees. Again, looking at this bottom left angle, cosine adjacent is going to be 1. Hypotenuse is going to be radical 2. That's also going to be 1 over radical 2, which is rad 2 over rad 2. And lastly, tan of 45 degrees. That's opposite over adjacent. Looking at this 45 degree angle, again, opposite is 1. Adjacent is 1. That's equal to 1 over 1, which is 1. Alrighty. So these are our special trig values, all of these guys. And they just come from our special right triangles. But what I want you to notice now is, just like on the homework, we should be seeing something pretty interesting. So I think there was a homework question that said, what do you notice about the two acute angles in a right triangle? So let me draw a right triangle, A, B, C. So if that's a right triangle, right, I think it asks what must be the sum of the two acute angles. Well, the two acute angles, of course, must also add up to 90 degrees, right? And that's because the measure of angle A plus the measure of angle B plus the measure of angle C, which is 90 degrees, that's a right angle, equals 180. So measure of angle A plus measure of angle B, well, those are 90 degrees. So the two acute angles in the right triangle are always complementary, right? Angle A and angle B are complementary. So this is pretty important because, well, if we look at this right triangle here, of course 30 degrees and 60 degrees, again, those are complementary. And if we look, sine of 30 degrees, that's the same thing as cosine of 60 degrees. And cosine of 30 degrees is the same thing as 60 degrees. Wow. Over here, sine of 45 was rad 2 over rad 2. Cosine of 45 was also rad 2 over rad 2. And 45 plus 45 is 90 degrees. Again, those were angles that were complementary, 45 and 45, right? 30 and 60, complementary. 30 and 60, or 60 and 30. So what we can say in general is that the sine of an angle is equal to the cosine of its complement. When you have an angle and you take the sine of that angle, that's going to equal the cosine of the complement of that angle. And that's going to be our theorem. We're going to prove this really quickly algebraically. It's not anything too difficult. So let's take a look in this triangle ABC here. So we've already established that angle A and angle B are complementary. So let's say I call angle A theta. What would angle B be? So if you want, we can do some really quick arithmetic. Angle theta plus angle B equals 90 degrees, because we know they're complementary. So we can say the measure of angle B is 90 degrees minus theta. All right, so this angle here I'm going to label as 90 minus theta. That might look a little weird, but I think it makes a lot of sense once we plug in a number. For example, if this were 50 degrees, right, wouldn't angle B be 90 minus 50, or 40 degrees, right, because 50 plus 40 is 90. And another example, if this were, I don't know, 70 degrees, over here that'd be 90 minus 70, that of course would be a 20 degree angle, etc. So in general, I can call angle A theta, and I can call angle B 90 minus theta degrees. And give me a second, hold on, I'm sorry. 我唔知啊呢。Okay, guys, what you money got there? Okay. All right. Sorry about that. I'll try to edit that out, but I'm not sure I know how to edit videos yet. So, all right. Anyway, angle A is theta. Angle B is 90 minus theta. So let's label these side lengths now. If I call that angle A, sorry, not angle A. That's opposite angle B, sorry. So I'm going to call this a side length of B. I'm going to call this a side length of A. And I'm going to call the hypotenuse C, right? Opposite C. So I can say that sine of theta is equal to opposite over hypotenuse. That's A over B. And let's do the cosine of the complement angle. So complementary to angle theta is 90 minus theta. And what is that equal to? Well, that's also equal to cosine of that is adjacent over hypotenuse, which is also equal to A over C. And I realize I messed up sine theta, I'm sorry. Sine theta is opposite over hypotenuse, which of course is C. So sine theta is A over C. Cosine of the complement of theta is also A over C. So what we can say is, in general, sine of theta is equal to cosine of 90 minus theta. In other words, we've shown this. The sine of an angle is equal to the cosine of its complement. And so this relationship makes sine and cosine cofunctions. So this means that sine and cosine are cofunctions. All right, and what does that mean? Well, that means this. The sine of an angle is equal to the cosine of its complement. All right, and I think you'll see this relationship is always true. Right, if this were 10 degrees, this would be 80 degrees. That would mean sine of 10 is equal to cosine of 80. Right? Sine of 20 would equal cosine of 70. Sine of 45 equals cosine of 45, as we see here. Sine of 30 equals cosine of 60, because 30 and 60 degrees are complementary functions. Sorry, complementary angles. Sine and cosine are cofunctions, and so that is true. So now that we know sine and cosine are cofunctions, we can solve problems like this one right here. If sine of 2x plus 4 degrees is equal to cosine of 4x minus 7, what is the value of x? Well, knowing that sine and cosine are cofunctions, sine and cosine will only be equal to each other when their angles are complementary. So to solve this problem, all we have to do is do 2x plus 4 plus 4x minus 7 and set that equal to 90 degrees. All right, I want you to think about that for a second, see if that makes sense, if that matches that. And solving for x here, we're going to get 6x minus 3 equals 90. 6x equals 93. And so x equals, what is that? Hold on, let me type that in real quick. 93 divided by 6. 15 and a half. All right, so let's check that real quick. Let's plug in 15.5. If I plug that in for x, this would become sine of 2 times 15.5, which is 31. We're saying sine of 31 plus 4 degrees, or 35 degrees, is going to equal the cosine of, so if we plug in 15.5, 4 times 15.5 is 62. 62 minus 7 is 55. That should equal the cosine of 55 degrees. And if you want to check that, you can actually type that into your calculator. If you type sine of 35 into your calculator, you're going to get approximately 0.57356 And if you're typing cosine of 55, of course that is going to equal the same thing. All right? If you want a little diagram, if that's 35 degrees, then that must be 55 degrees in a right triangle. So sine is going to be opposite, or this length. I'll call that the height, right? No, not height. Let me call that a leg, and let me call that h, right? Sine of 35 would equal the length of that leg over the hypotenuse, and cosine of 55 in the same triangle would have to be the adjacent side, which is the length of that leg, over again the hypotenuse h. Cool? Alright, so here's one more problem. We can actually solve this without trig, but let's use trig to solve it this time. So the Nile River has overflowed and covered its entire surroundings except for the tip of the Great Pyramid in Giza. An expedition was sent to find how high the water has risen. The people measured the edge of the pyramid that's above the water and found it was 72 meters long. Right, so I guess it's a semi-realistic example. Like if you're on a boat, you can't really measure that length or how deep it is. Maybe you can measure how deep it is, but maybe you couldn't. Maybe you can only measure this. And so if you can only measure that and you found out it was 72, and you already knew the length of the pyramid was 180, and at the height, or the vertical height of the pyramid was 139, how can we find the level of the water above the ground? So if you like, I think it's a good problem to try. So you can pause the video, take a couple minutes, but here we go. If we know this is 108, then this side, sorry, not 108, 180. This side should also be 180. Did I mention that? No, I did not mention it. But it did say it's a pyramid. I know we haven't talked about pyramids yet, but in a pyramid, these two sides would be congruent. So if that's 180, this would be 108 here. All right? And what are we looking for? The level of the water above the ground. So if that's 108, I'm going to call this h. That's what we're looking for, h. And vertical height, so that's going to be an altitude. That's going to be a right angle. And if that angle is 90 minus theta degrees, well, this angle over here, that has to be theta degrees, right? Because 90 minus theta plus theta is 90 degrees, and we know these angles are complementary, right? 90 minus theta plus theta equals 90 degrees. The thetas will cancel out. 90 is 90. They are complementary. So, what are we looking for here? We're looking for the height. So I'm going to use trig to solve this. So, in this triangle, cosine of theta would equal h over 108. Alright, so I use cosine because I was thinking, well, what side lengths do I have in this triangle? What do I want to figure out? So I have the hypotenuse, and I wanted to solve for h, which is the adjacent side. So I use my trig ratio of cosine to get h over 108. In that right triangle. Right, but I have another right triangle here, which is this guy. And this also has an angle theta. So therefore, if that angle is the same, and these are both right angles, we can assume, right, then they're similar triangles. So we can also solve for h using similar right triangles. But using trig here, that's also theta. So let's figure out what cosine of theta is in this triangle. Cosine of theta in that bigger triangle is going to be adjacent, which is 139, over the hypotenuse, which is that entire length, which is 180. Right, so if cosine of theta is equal to this, and cosine theta is equal to that, we can do a substitution. you can say 139 over 180 equals h over 108. Alright, this problem we could have done just using similar triangles. We could have shown that these two triangles were similar, this pink one and the black one, right, by angle, and then we could have just done CSSTP, corresponding sides and similar triangles are in proportion. Simple proportion, you get the same thing here. And cross multiplying now and solving for h. Let's see what we get. 139 times 108 divided by 180, and the height is 83.4. Let's redo the question. What were the units? They were in meters. So what's the level of the water above the ground? 83.4 meters. Right, we did not need to round because it was a nice number. Alright, and that is it. I hope you guys are doing well, and I'll see you all next time. Bye-bye.